Now we saw expansion with respect to a row. We're interested in expansion with respect to a column. For example, take a look at this matrix. This matrix has 0 and 0 on the second column. So we're going to use this column and do the expansion. Pay attention, please. Remember the definition. When you're expanding with respect to a column, your I is changing. Expand by cofactors along the second column. So take a look. What I'm going to do, I'm going to take the entry on the first row and second column. So first row, second column, multiply that by the cofactor for the first row and second column. So this guy is the entry on the first row and the second column, A sub 1 and 2. And I'm going to multiply that by the cofactor for the first row and the second column. Then add it to the entry on the second row, second column, which is 1, multiplied by the cofactor for the second row, second column. And finally, I'm going to do the addition for the entry on the third row, second column, multiplied by the cofactor for the third row and the second column. So first of all, the cofactor for the first row, second column is equal to -1 to power 1 plus 2, which is 3, multiplied by the minor for the first row and the second column. How are we going to do the calculation? This is equal to, you're going to delete the first row and the second column to get this 2 by 2 matrix. This is your minor for the first row and the second column. Now to calculate the cofactor for the second row, second column, by definition, it is -1 to power 2 plus 2, which is 4, multiplied by the minor for the second row, second column. So let us do the calculation for the minor for the second row by deleting the second row and the second column by deleting the second column. And finally, the cofactor for the third row and the second column is equal to -1 to power 3 plus 2, which is 5, multiplied by the minor for the third row and the second column. The minor for the third row and the second column can be calculated by deleting the third row and the second column. So what are we going to see? We're going to see that, hey, my first entry is 0. This A sub 1 and 2 is 0. So if you want to do the calculation, go ahead and do the calculation, but this is just 0. I don't need C sub 1 and 2. Then the second entry is 1, which is A sub 2 and 2, and you're going to type it out and multiply by the determinant for this matrix here, 1 times 3 minus 2 times 2, and remember that -1 to power 4 is positive. That's how we end up with just +1. And finally, the last entry is equal to 0. A sub 3 and 2 is equal to 0. So you don't even have to calculate this. That's how you end up with 1 times the determinant of this matrix, 1 times 3 minus 2 times 2, which is 4. And this is the determinant of this matrix by expanding along a column, everyone.